The no bits left behind pattern. What is that? Well, given a storage hierarchy with the different levels, a query or whatever you want to do on the storage hierarchy, some data, what is the solution? The solution how to organize your data is that for all levels in the hierarchy, you try to use a minimal number of bits for the interesting data. You don't waste any bit for data no one is interested in. You should only load data in the storage hierarchy you actually care about. You shouldn't load any data, any bits, any bytes you're not interested in. That is not required for any computation you're performing. Well, that sounds very high level. Indeed it is. We will look at an example in a moment, but just for the advantages and disadvantages. Advantages are no bit wasted. That is, of course, an ideal scenario you will hardly reach at all, but that's the design goal. So no bit should be used for data nobody cares about. And this also implies no bandwidth should be wasted for moving around unnecessary data. It's not only about the storage space in the different levels of the storage hierarchy, it's also moving the data around, which costs something, and we want to avoid those costs. Well, what are the drawbacks? Space optimality and CPU optimality are often in conflict, so it's not so easy to map the data in a way that we don't load unnecessary data. Therefore, we often have to design the data layouts for a sweet spot. So just loading the interesting bits is very, very difficult because it requires different CPU effort to reorganize the data usually. So we somehow have to find a good trade-off. Well, let's make it more concrete. Let's look at an example. And I think this explains very well what this pattern is about. So assume we are in between these two levels of the storage hierarchy. We have main memory and we have flash or hard disk. It doesn't matter. So we have pages and those pages contain tuples. So here I have a page 12 and a page 42 and there's a tuple on this page and there's a tuple on that page. Now the database system or anyone else who cares is interested in that particular tuple. Let's say this one. So as the smallest granularity we can access from hard disk is a page, we have to load the entire page into main memory. Let's do that. Now we have a copy of the page in main memory, which means, in other words, we loaded this 4K page even though we are only interested in this tiny little tuple. So maybe this is just, let's say, 12 bytes. Maybe it's 12 bytes. 12 byte tuple and a 4 kilobyte page. Or it may even be more extreme, a little tiny piece of data we're interested in. So let's assume we're also interested in that tuple, so we also have to load this page into main memory. So we have a copy now, and now the computer program can operate on those two tuples. And this is, of course, very ineffective because just for loading these two tuples, we had to load these two pages. So we're wasting all of the blue stuff. The blue stuff is also sometimes referred to as cold data. So this is the cold data, all the blue stuff, all the data on the page that does not belong to that tuple is called the cold data. And this is the hot data, of course, this tuple. That's what we're interested in. That's hot. And the problem here is that we loaded a lot of cold data into main memory. Let's assume it's never used by anyone, even though we had to load it because this is the granularity we have to use. So in this situation, we are wasting 2 slots in the database buffer, or whatever technique you use, you're wasting 2 times 4 kilobytes of main memory just to access those 2 tuples. Well, and in this situation, it would really be better to move the hot data on a subset of the pages. So in this example, it would be better if in the first place, if you understand that those tuples are accessed very often and maybe they're accessed together, then a viable solution is to move those 2 tuples on the same page 12. Now, if anyone is interested in any of those tuples, you simply load that into main memory and then whoever is interested in that one can work on this tuple. But then if the second tuple is requested, okay, then we simply work on that tuple. There's no loading we have to perform. We don't have to waste main memory for just loading page 42, as this hot tuple already sits on that specific page. So here we are wasting way less data. The ideal scenario in the context of that no bits left behind pattern means we want to minimize this cold space, stuff that's not requested, stuff that pollutes the memory hierarchy with data no one cares about. So one important design goal we will revisit several times throughout this lecture is to organize data in a way that only the hot data gets loaded into higher levels of the memory hierarchy. If your data layout is like in my previous example, let's go back. If it's more like this, and you always pollute main memory in this example with cold data, you're wasting a lot of resources, and that's not what we want to have. Again, keep in mind, this effect not only happens between those two levels of the storage hierarchy, this effect may happen in between all levels of the storage hierarchy. So no matter from which source level you load it into which target level, it's the same effect, and the same design goals should be kept in mind. Try to avoid loading cold data. If you liked this video, don't forget to hit the like button. Thank you. So if you want to see more database videos, be it in English or in German, take a look at my website datenbankenlernen.de. It has a couple of English and German videos. You can also subscribe to my YouTube channel, Jens Did, or you look at our website, infosys.uni-saarland.de. See you there!